Imagine spawning different weapons when a player reaches a certain area, swapping out enemies as the difficulty increases, or even changing entire environments as players progress through your experience. In this tutorial, we'll show you how to make all of these possible by mastering asset lifecycle management in Worlds. I'm Andy, and today I'll be guiding you through these techniques that will take your worlds from static environments to dynamic interactive experiences. Managing your assets efficiently isn't just about creating cool effects, it's essential for building worlds that perform well. The methods we'll cover will help you to create more interactive and responsive environments, maintain better performance even with complex worlds, implement gameplay features that would otherwise be impossible, and reduce memory usage while expanding what your world can do. In this tutorial, we'll explore three key techniques. Asset spawning, how to make objects appear and disappear during runtime using both simple and advanced methods. Object pooling, a powerful optimization technique that reuses objects instead of constantly creating and destroying them. And world streaming, which allows you to load entire sections or levels into your world on demand. By the end of this video, you'll have the knowledge to implement these techniques in your own worlds, creating more dynamic experiences while maintaining great performance. So let's get started. Asset spawning allows you to add and delete objects individually or as a group or as a set of objects during runtime. Some assets, such as your skybox, can be spawned statically by placing them in the editor, but other gameplay elements may be dependent on player actions or on the game progressing. That's when dynamic asset spawning comes into play. Think about selecting different weapons, loading different enemies, loading night or day environment elements, and much more. Keep in mind, virtually any entity and most gizmos can be turned into an asset. Let's look at how to turn something into an asset. So I've added this sticky ball to my world. So I've searched in the library for a sticky ball, and that's what this is. I can turn this into an asset by right-clicking it in the hierarchy over here and selecting Create Asset. I can give it a name, Sticky Ball, a description, and then make sure that I've selected Template Asset. And then I can choose a folder where to put it. For now, I'm just going to put it in the default My Assets folder and click Create. So now that that's happened, you can see that an asset has been added to my assets down here. And if I click and drag that, I can add it to my world. So that's how we create assets. It's important to understand that each dynamically spawned asset takes up CPU and GPU resources when they're loaded or visible. This means you need to be strategic about when and how many assets you spawn to maintain good performance. It's also important to destroy assets once they are no longer needed. To spawn assets in Worlds, use the SpawnController API. So let's have a look at using the SpawnController API to spawn our sticky ball that we've just added here. I'll just move this so that it's nice and visible when I preview the world. And what I'm going to do is I'm going to create a new script. This is going to be called Sticky Ball Spawner. And then hit Enter. I'm going to use the build menu to add an empty object. And this is going to be an empty object that holds the sticky ball spawner script. So I'm going to select the attach script property whilst selecting the empty object I've just created, and make sure that it's my script, my sticky ball spawner script that I've just created. And I'm also going to rename this object to sticky ball spawner so that I know that this is the thing with that script attached to it. Let's now go into edit the script. So I'm going to click on the scripts menu, scripts panel, and then on the script, the three dots, and open in external editor. So in here, what we need to do is use a SpawnController. And if I just type SpawnController and then control-click it, it will give me all that I need to know about what a SpawnController is and how to use it. Okay, so when do we want this to spawn? Let's say when the player arrives in the world. So in our pre-start function, which if you remember from one of the previous videos, the pre-start function runs before the player enters the world. I'm going to add I'm going to connect to a code block event. This.connect to connect code block event. I'm going to use this.entity. It doesn't really matter in this situation what I'm listening for, but it needs to have an entity. So I'll use this.entity. hz.codeBlockEvents.player enter world. And then let's do our callback function here, player in the brackets. And there we go. So in order to spawn something, I'm going to need to create a spawn controller. So this is going to be like a temporary variable. So I've got const spawn controller equals new spawn controller. Now, if I type new spawn controller and put an open bracket, IntelliSense will tell me what things I need to include in those brackets. It's going to ask me to include an asset, a position to spawn it, a rotation to spawn it at, and a scale. So I'm going to need to supply those things. So let's go up, and it's going to error until I do. Let's go up to our props definition so that I can supply those things to the spawn controller. So the things we needed were an asset. So this is my reference to my sticky ball asset. So the prop type is asset for this one. We need a position and a rotation, and we can get both of those things from other things in my world. So let's add an entity here. So position reference. And this is going to be an entity that supplies us with our position and our rotation. Okay, so we got that. In my spawn controller, I will use this.props.asset, sticky ball asset from my props. I will add a position, so this.props.positionReference.position.get, open close brackets, a rotation, this.props.positionReference.rotation.get, and it needs a scale. For the scale, I will just use hz.vec3.1, which is a scale of 1. Great. Okay, so it's giving me a red line here. It's saying it could be undefined. The thing about props is that they may not be set. So we actually want to check that we have set something here before we run this. Otherwise, TypeScript will have these red lines and it won't compile and it won't work. So if this.props.stickyballAsset is not equal to undefined, open and close brackets, and we'll just put that in there. It also has a red line for these position reference, so let's check that that exists too. This.props, so I'm doing and this.props.position reference is not equal to undefined also. So that should get rid of my red lines. Let's see if that is compiling. Yeah, so we've got it compiled. Now, on my spawner, I have these 2 empty slots in the properties that I need to fill. So let's put the sticky ball, actually the sticky ball asset. So if you saw, I tried to grab the entity. It's not the entity, it's the asset from the asset library at the bottom. So I'm going to drag the asset from the asset library and put it into sticky ball asset. And then for position reference, I'm going to include, let's create another empty object that's next to my sticky ball, like this, something like this, anyway. Okay, so this is going to be my rotation and position reference. Let's rename it to that. And then let's use my sticky ball spawner and drag my position reference into that there. Okay, let's go SpawnController.spawn to spawn our asset. So this is saying when the player enters the world, create a spawn controller and spawn the asset. Yeah. Okay. Clear my console. And there we go. So now I have two. So basically what we've done here is we've looked at using a spawn controller to spawn an asset. The way the spawn controller works is you have to create a new spawn controller. That gets stored in a variable for reference. And if you wanted to, you could make this a class level variable so that you can use it throughout in lots of different functions, or you can use it like I have here in a temporary variable, and then you call spawn on that spawn controller. This spawn controller adds more capability by allowing you to manage the different states of an asset lifecycle: load, spawn, pause, unload, and dispose. This type acts like a container where you have to specify the asset as well as the position, rotation, and scale that the asset should have once it appears in the world. Creating or deleting an object is a heavy operation, and if you do it too often, the performance of your world will suffer. Object pooling is an approach to tackle this problem. Object pooling consists of keeping a set of objects hidden in the world, ready to move into the playable area when needed. This might be advantageous for performance purposes. Instead of adding and deleting new entities very rapidly, it's sometimes better to just activate and deactivate the assets. When working with a pool of assets, it's important to consider how many assets you will keep in the world. This calculation varies greatly depending on the use case. For example, for environment interactions like monsters or fireballs, the number of assets should be the same as the maximum quantity of concurrent objects that you expect to activate in your experience. So, for example, if I only ever expect to have a maximum of 5 monsters in my world, I would want to make sure that there's at least 5 monsters in my object pool. However, in the case of player assets like heads-up displays, the number of queued objects will be the same as the max number of players configured for the world. So, for example, if I have a UI element that shows a player their score and it's local to that player, I'll need one of those for each player. This could be 20 if your maximum player count is 20 for your world, or 5 if it's 5, and so on. Object pooling is a common technique used in game development. You can implement it in TypeScript in worlds. In simple terms, here's how it works. For environment objects like projectiles or collectibles, you would typically create a list or array of objects at the start of the experience. Keep track of which objects are currently in use and which are available. When you need an object, find an unused one in your list, position it where it's needed, mark it as in use, and then when you're done with the object, hide it, mark it as available again instead of destroying it. For player-specific objects like personal UI elements, you might organize your pool differently, perhaps using a player ID to quickly find their specific object. So each player would have their own set of reusable objects. The most important part of any object pooling system is having an efficient way to track which objects are available to use and which ones are already active in your world. Okay, so let's take a look at object pooling using the chop and pop world template. We'll have a look at some of the examples that we can see in that world. Okay, so in chop and pop, you'll see that there's these floating loot items that you can run around and pick up. These are ammo, and so rather than needing to spawn new ones of these every time we want one to appear or destroy one when we want one to disappear, the way that this world works is we actually have the loot already built into the world. So it loads during the world startup. You can see the loot in this ammo loot group here. Each of these items is one of those things that we just picked up. So we already have the full breadth of all of the ammo loot that we'll possibly want in the world within the hierarchy before the world's even loaded. Each of these entities has a script attached to it, which is the pool item loot or pool loot item script. Let's take a look. So in the pool loot item script, which is this one, you'll see that it says add self to pool, which is this function down here. And it looks kind of complicated, but basically what this is doing is it's trying to it's looking for an object pool that will look after this. And then it's saying, I am an asset, I'm an entity in the world, and I want to be added to a pool. Somewhere else in the world, there is the object pool for this. If you go to the ammo loot pool, you'll see that it has an attached script, object pool over here. And what this is doing is it's listening out for some entity to say, hey, I want to be added to a pool. And then it adds it to an array. You'll see it says this.freeentities.add entity. And essentially that's adding at the beginning of the world, it adds all of the ammo loot to an array called this.freeentities. And then when it wants to spawn one, rather than using the spawn controller like we did before, it essentially gets hold of one of those that is available, one of the items in the free entities array, and it removes it from that array. Then it adds it to a different array called allocated entities. This is so that if I wanted to add lots of items quickly, one after the other, like the free entities array only has entities in it which are available for me to use. And then it runs the onAllocate function on that entity. If we go back to the pool loot item, you can see that there's this onAllocate function here. And all this does is it makes it visible. It moves it to the correct location. It sets its rotation to be what it should be. Make sure that it's not set to collected and starts playing the VFX gizmo. When the object is picked up, it runs the onFree function. And what this does is it makes the entity invisible, moves the entity back to an invisible position, to its original position. And if we go to our world and we see where these actually are, so in here, if I click on one of these and press F, we'll see that it's here, outside of the world. This area is not somewhere that players can get to. So essentially, all it's doing, all this code is doing, is it adds it to a pool. The pool then decides when a new one needs to be spawned, and it passes it a position in the world, turns it on, waits till the player collects it, at which point it turns it off and moves it back over there outside the world. World streaming allows you to place large chunks of objects or levels into a world by streaming the content of another world instead of loading individual objects into an experience and having to calculate where to place them, either with reference position or hard-coded values. You can be more efficient and load an entire level into your world. Imagine you're creating an adventure game with multiple distinct areas, perhaps a medieval village, a haunted forest, and a dragon's cave. Each area has completely different assets, lighting, and gameplay elements. World streaming would allow you to keep each area as separate published worlds and load only the area that the players are currently in. Switch to a new area when the players as a group reach a transition point and maintain better performance since only one area is loaded at a time. This approach is much more efficient than trying to place all of these areas in a single world, which would likely exceed capacity limits and affect performance. In order to use world streaming, you will need to create the sublevels. These are independent, undiscoverable published worlds containing all the objects that you would eventually stream into the main world. Configure the main world by adding sublevel gizmo and modifying its attributes to reference the sublevel that you will stream. You can also specify the default state to active in edit mode to make it easier to move and rotate the intended location of the stream level. After you're done with this configuration, you can change it back to unloaded. Create the necessary script and enable the World Streaming API. This will unlock all the methods and classes that will allow you to change the state of the levels during runtime. The state of a streamed asset could change between multiple states: active, then loaded, loading, not ready, pause, unloaded, and unloading. These are activated as a result of calling the methods of activate, hide, load, pause, and unload. Now that we've explored the three main techniques for asset lifecycle management, let's talk about how to choose the right approach for your specific needs and how to avoid performance pitfalls. Understanding these considerations will help you create worlds that remain smooth and responsive even with dynamic content. So here's some tips to help you decide when to use the techniques covered in this video. So for asset spawning, for more precise scenarios, when you might need to interrupt the spawning process, pause, or when it would be beneficial to preload the asset before they are spawned, to increase loading times when the asset is finally requested. Object pooling, ideal when you need to rapidly create and destroy the same assets, for example a projectile or a monster, for assets associated with players like a HUD, and if the world capacity allows you to keep these assets in the world all the time. World streaming, effective for loading full sections of a world, sublevels, but choosing the right technique is a question of performance too. Regardless of the feature that you decide to use, consider that it's possible to reach the capacity of the world if any of the budget limits is reached, even at runtime. After this point, assets may fail to spawn due to world capacity limits. So make sure to keep track of the assets that you have added dynamically and delete them before adding new ones. Remember these important performance tips. Both spawning and world streaming require your device to load and render new visual data, like meshes and textures, which takes processing power. If you try to spawn too many things at once, players might experience a sudden drop in frame rate and might make your world feel really laggy. To prevent those performance drops, avoid spawning many objects simultaneously. Instead, space them out over time by using timeouts to delay the next spawn, or chain the next spawn to the success result of the last one. This is another reason to consider object pooling, since the objects are already loaded and just hidden. Activating them doesn't require the same processing power as spawning new objects. Now that you've seen what features and techniques are available in worlds for spawning, pooling, and streaming assets, feel free to experiment and explore which technique or combination of techniques would be most suitable for you. Remember that each technique has its advantages and disadvantages, and it's all about balancing between performance and the interactivity you need in your world. Asset spawning is great for simple dynamic elements, but remember that spawning too many objects at once can impact performance. Object pooling is excellent for objects that appear and disappear frequently. It saves processing power by reusing assets instead of constantly creating and destroying them. And world streaming is perfect for loading entire environments or levels, allowing you to create experiences that would otherwise be impossible within capacity limits. As you implement these techniques, keep an eye on your world's performance using the performance panel. If you notice frame rate drops, consider revising your approach by spacing out spawning events or using object pooling more extensively. I look forward to seeing what you do with object pooling, asset spawning, and world streaming, and I'll see you in Worlds.